Yeah, I will very swiftly introduce myself. So my name is Sussitz. I'm a senior software developer at Dynatrace. I'm working mainly with Java. I do a little bit of C++ as well. But don't worry, we're not going to talk about either of those today, at least not a lot. We are going to talk about Docker, how we can use it, and how it's going to help us. So I'm a firm believer that great software is not built because you are setting out to build great software. I think great software is built because there's a need for it. Somebody one day gets up and they think to themselves, well, this really sucks, I cannot take it anymore, and I'm going to solve this issue. And there are multiple examples for that. So I think one of them is Spring Boot, for example. Like, who here is working with Spring Boot? Maybe raise your hands. Who here has used only Spring without the boot before? Me too. And I remember it's really terrible. Like, Spring Boot is already really bad. But Spring is a lot worse. You have so many XML files, so much configuration to do. It's really bad. And here's a quick picture of me doing my Spring Boot. I'm already struggling. Now imagine it's just Spring. Like, I'm completely helpless. Another great example is, in my opinion, TimeLeaf. So a couple of weeks ago, I was working on a very simple web application, and I needed some front end. And I really don't like front end, and then try to avoid it when possible. And so this was very handy because I could ditch almost all of my JavaScript and do the server-side rendering, which was very nice. So I was able to write most of my code in Java and have still a presentable front end. And I think another example of software like this is Docker. I'm sure we all have had the problem before. We built a great application. It works on our machine perfectly, flawlessly. Then we deploy it to a server or something else, and it's not working anymore. The paths are incorrect, the tools are missing, and everything is terrible. And I believe somebody in this moment, they thought to themselves, well, what if I could just ship my own machine? And I believe this is how Docker was born. What if we just ship our own machine? And yeah, this is more or less what this tool does. Docker. It allows us to ship our own machines, our own environments, and have a very similar setup on our deployments across all of our deployments, which is very neat. Now, how does it work? What is Docker? How can we use it? So Docker allows us to run our application inside of our own container. So what is a container? In a container, we have the option to put all of our needed tools, so that includes our application code, all of our dependencies that we need for our application code, configuration files, as well as system tools, settings, environment variables, and all of that stuff. We can all put it into our container and then ship the containers and have everything we need inside of our container. So with Docker, we are able to isolate our application from the rest. So from our host system as well as other containers. It's more lightweight than a full virtual machine, but we still have the isolation. And it's open source, which is nice. So how do we use it? How can we use Docker? How does it work? Basically, we need a Dockerfile, so this is where it starts. Then we need to build our image. And then we can run this image and have a container running. Our Dockerfile would look something like this. So this is probably the simplest Dockerfile we can imagine. We start with a from. This is our base image where we are starting from. Then we do some custom configuration, and we have our entry point. So if we start our image, this is the command that our container will run. So how would it look like? For base image, we could use something like an Ubuntu latest. Do stuff what typically we could start with installing some tools, updating our operating system, create a working directory. So this would be a directory where we want all of our stuff to happen. Copy our sample application. So in our simplest use case, we have some sample application. We just copy it onto the container. And then as entry point, we just run our application.
One crucial point is missing. You need to define a user.
I guess there's still always somebody said a user is missing. It's always a way to improve an image.
Yeah, it's great to improve the security because if you start doing it like that and you're not using rootless Docker, We're going to run into troubles sooner or later.
Thanks for the notification. I haven't worked with Docker in a long time, but yeah. So always secure your images. This is how we built it. So just Docker build. And this is how we run it. Now onto the practical stuff. We're actually going to run some stuff because live demos have never gone wrong. So I'm sure you're all doing that when we start with a new tool. First thing you're doing is to just make sure that everything's working. So one way to do that with Docker is to just run our Hello World example. We can, just to make sure that our Docker is set up correctly, that everything's working. And as you can see in my example, that is the case. But we want to build our own files. How can we do that? I have an example repo right here. Now let's build our Docker Hello World, probably a smart starting point. So we are going to choose a start image. I just have, let's take an Alpine latest. The only thing we want to do is just print Hello World. Now if we run that, and if I've done everything correctly, we should be able to see a custom built Hello World Docker image. So I hope that's working. And there we have it, Hello World. But that is hardly useful. We would like to do a bit more. I have written a very beautiful application, a web application for that. And we can use this as our sample application. So this is the only bit of Java you're going to see today. Just to make sure that everything's working, it's a Micronaut. And this is now the web app that we have. You probably have a few questions like,
that's the actual website.
This is the website. It's beautiful, I know it's beautiful. If your website also, if you want some consulting, I can help you with that later. And some of you may be thinking, why are you using a Java service to serve a static website? To that I have to say, because I like Java. So yeah, this will be our sample website for the presentation. Just executing full screen right now. So first thing we could do is to have, if we have an executable, we can just copy it onto our Docker container. I have this right here, so I used a Java command to build me an executable with a custom Java runtime. And if we now change our Dockerfile, we can copy that onto our container. So let's do that. I'm going to change to an Ubuntu now, because it's a little bit, it can be a little bit easier. And if we change, if we give this a new start command, we can now build a new container. Did I? I think it should be, it should be correct. So now if we run our container, it's now not going to do anything because it's just sleeping indefinitely, but we can open a second window. And if we look at our running Docker containers, we should be able to see the container that we have started just now, and we can then exit in, run a bash inside of our container and enter our container. So now we are able to do stuff in our container. We can see what files we have, and we could also copy something into our container. Just noticing one thing. Like this, we will, damn it. Like this, we will be unable to actually see our website from inside the container because it's not able to do a port forwarding. We need to configure our Docker container. I just need to. Is it? Ah, yeah, sorry, of course. Yeah, the cable is.
I touched it too much.
Is it working again? That's not ideal.
Sorry, I shouldn't have touched it in
That's
the
okay.
first place.
No, it's working. Is this big enough?
Yeah.
So I'm just going to kill the container again.
So that's an important connection.
So now if we start our container with the right start command and actually have the port forwarding enabled, we will be able to run our server from that. So we can use a Docker command to copy our file inside of the container.
Into the running container.
Into the running container. I just need to figure out the commands in the right order. I'm really sorry for that. So you're able to add stuff to the running container, also copy stuff out of the running container. So now in our case, we are going to copy our web application into our running container.
And I guess Java is already installed on the Ubuntu.
On the Ubuntu, we don't need it because we have the full Java runtime bundled inside of our application. Or not the full, but a special runtime.
So use macro.
Now you can see that our sample application is present inside our container. Now if we move to the right location, we are able to run it again. And you can see that our website should be available again, and it is. So now we have our beautiful website running inside the Docker container. But some of you may be thinking, because it's an outdated version.
We really know it's working, actually.
It's still localhost, but the colors are different.
Yeah, the colors are not moving anymore. Sorry for that. But we don't really want to set up our Docker like that. To start a container, to manually copy stuff into that, to exec into our container, run the application, that's quite a bad workflow. So we are able to do it better. And for this, we just need to modify our Dockerfile a little bit more. So this is our current file. The first thing we want to do is to just copy our application into our container. So first, let's set up a working directory. Let's call it app. And if we copy our sample application, can I just copy path? And now our sample application will be available inside of the container. So now we can also change our start command. So now we give it an actual entry point. Do I have? Yeah. Point. Now we can do that.
Why do you sometimes use the square brackets and sometimes write the command just like it is? When do you need which syntax?
I have to say I would need to look this up on a per command basis.
Mm-hmm.
Really sorry for that, but a good question. But yeah. So just now, let's see if our new and improved container is working. So we're going to build it again. Now we should be able to run this. And we have our first problem.
Quotes.
Seems like the location is incorrect. The quotes, thank you so much. We're missing that, of course. So then let's run our container again, run our build again. And now we should be able to run this with port forwarding, of course, while otherwise we're not going to see our application. And I think it's still, the container is still running, yeah. Like a live demo can be so stressful.
No pressure though.
And our website is running again. And if you have a simple Docker use case, then this would be already it. If you are able to build your application rather easily, then now you would just improve security probably a little bit, set up a user, maybe use a different base image because you don't want to use the biggest base image if you are actually running this in production. But for simple use cases, you are pretty much done now. But not everything is a simple use case. Maybe sometimes your build is a little bit more complex. Maybe you actually need to do some native building. Maybe the Java building is more involved with the JavaScript. And there are some, just the setup takes a lot more time. And then in that case, it might make sense to also build your application on Docker image. And how are we able to do that? So I have built this sample application with a Java command that I have put in my cheat sheet, so this one. And we can just move this into our Dockerfile and run it from there. So first we need to change the base image. We are going to use a base image that has Java installed because now we're actually going to need it in order to package our Java application. The next thing that we will need is this command. So with this, we will be able to package our application. And now we just need to find some way to copy the files that we want into our container. So we are able to move stuff at container creation as well into the image, at image creation into the image as well. What we want would be our build files. So if this is the file that we want to include in our build. Now we can copy this into our build. We can also create a few more folders in order to make the management a little bit easier. And now we are able to copy this into our input. We can change the entry point as well again. So it's the output node. And I believe the rest should be correct. Now if we try to build a new container that is already doing part of the build inside of it, we should be able to see that. As you can see, now this command is taking a little bit longer than it previously did. The build is successful, and we can check if everything is running. And that looks good. But still part of the build is outside of the container, so let's move that in there as well. And now we have another problem. Now that our container is also starting from a bigger image, now we have a full Java development kit inside of our container. We have our source files in there, we have some jars in there. So all of the stuff that we don't really want to have inside of our container. So we're also going to solve this problem. So let's first enhance our build further. We're going to change our base image one more time. Now we're going to use a Gradle base image. So now with this image, we have JDK 21 installed as well as a Gradle. So we are able to compile our full Java application. Because I don't believe you want to see me type out the whole container, Dockerfile, I have the file already pre-created here. So what have we changed? Yes, this is, thank you so much. I could also increase the zoom a little bit. Yeah, that looks good. Okay, we're starting from a Gradle 8 with JDK 21. We create a working directory again. Now we are copying a little bit more into our container. So you can see some Gradle settings, our Gradle wrapper. Then we're copying the Gradle folder. And we're copying our source. the next thing we're doing is running our Gradle build. So this will create our Java application. Then we run the same command from earlier, so we create our executable. And now this container is done. So this would be our build container. This is a container we are using to building our application. And only for building it, for the deployment, we're going to use something different. Here we want a slimmer image because this has two advantages. It's less size on our servers, on our AVS, EC2s or whatever. And also because it's a slimmer image, it has potentially less vulnerabilities, so it's also safer. We're creating a work directory again. And just like earlier, we're copying our files into the application, into our image. And you may see that this looks very similar to one of the first containers we built. It's just we copy our executable and then we run it. So now if we run this, we should be able to have our final container, hopefully. So now it's doing a little bit more. The Gradle file also takes quite a bit longer. I think it should take around 60 seconds. Once during a presentation, I accidentally recompiled some native program and we were waiting for 10 minutes. That was very awkward, but now this is completely fine, manageable. Just going to continue talking until it's done.
It's only this time takes long.
Yeah, exactly. It's with Docker only. Sorry?
Why does it only take so much time on the first run?
It's a very good question. Every step inside of the Dockerfile represents an extra layer that's added on top of our image. And so if you change one layer, it's only starting from this layer and then rerunning everything down below. But as you can see, our command has failed. And this is also one of the nice things with Docker. We see what has failed. So we can see our run Gradle build has failed. And we already get a rather useful error message somewhere if I'm able to find it. I think it's further. Yeah. So really, so it's rather hard with the big font to find it somehow. There we have it. So we can see our Micronaut version is missing, and that is because it appears like we are missing the Gradle's property file. As you can see, this is something we have available inside of our normal project. Here it is, and it just defines the version we're using. But I unfortunately forgot to copy it into the container, so we can just do that here. And yeah, now we actually need to run the Gradle command again because some files have changed earlier. So now it's rerunning the Gradle build, so it's creating a new layer. That is now going to probably take around 50 seconds again. Really sorry for that.
In the meantime, could you show the Dockerfile again?
Yeah, sure.
Because maybe didn't get it, but
okay. You import Gradle, so this base image, or this image here, as builder. And
Exactly.
That's how you, in the second step, you can import it from builder.
Yeah.
Oh.
Can you show that again?
Sorry, what do you mean?
So here, on line 1, you
Yeah.
import it, like you alias it as builder.
Exactly, and this is how I'm using it later. Exactly.
here you use it. Okay,
Exactly.
That's very cool.
While we're at this step, scroll a little bit further.
Yeah.
The problem is you're using an image which has Gradle inside, right?
Yeah.
But on run, you're executing the wrapper. the Gradle
Yeah,
wrapper.
that's a good point. Maybe I don't need that.
That's why it's downloading, because that's why it's saying that 10%. That's why why are you using Gradle wrapper? Because
That's a good point. Yeah, somebody mentioned that I already have Gradle. I wouldn't need to. I have the Gradle wrapper. I don't need to actually use a Gradle image. But yeah, there's always room for improvement. But now we have a working image, hopefully. So let's try it one more time, potentially the last time. And it doesn't seem to be running, unfortunately, again. It told us that it cannot find this. And now this can be rather cumbersome. It can be difficult because you have all of those steps. It can be difficult to see what's actually going on inside of your container. What I like to do, or what I have done a lot when I was setting up those demos, is we can override the entry point somehow. That looks good. So we're able to overrun the entry point. So we want a new entry point because our original entry point seems to be incorrect. And we can enter our image. We want to run a bash as a new entry point to have an interactive shell that we can use. So we can check what's actually going on inside of here. And we can see there is our sample application. And just as we would expect, there we have our executable as well. And it is working. So seems like the path is incorrect. This is the path that we currently have. And this is the one that we would like to have. And I think this is I know that this is the culprit. So let's do it one more time. This time
we are fast because it's only the second image that changed.
Exactly. This time we are really fast because the only thing that changed is the entry point. So it's going to reuse all of the previous layers. Now we can run it. Again with a port forwarding. It's starting correctly. And if we reload our page, we have the nice colors again. So this is how you can see that it's working.
What was the problem with colors before?
I had an outdated application, locally built. But now we rebuilt everything, so this is why the colors are updating. At one point, I didn't have the moving colors from the very beginning. I just didn't recompile the Java stuff.
Maybe a good point. How do you keep track of multiple images lying around? You had these long hashes. How would you usually?
Yeah, you can. Usually, you give them a name. That makes it a lot easier. This is how you would see the images if I'm able to type that correctly. Yeah, and as you can see, I've done a lot of work today. I mean, not that much, but still. So yeah.
At some point, you have to remove all of them. And
Yes.
It's a new laptop.
So yeah, after today, I'm probably going to wipe all of the images. But yeah, to recap, Docker allows us to encapsulate our application inside of a very slim container. We can have all of the tools that we need to run our applications inside of the container, and then we can basically deploy our own machines. Any questions?
Yep. I have one list.
I feel like that you know more about Docker than I do, so I'm already quite scared about the questions. Please go ahead.
So Dynatrace is a big company, and I think last year you had like 1.5 billion in revenue.
Mm-hmm.
If you're using Docker Desktop, that's going to cost you.
We are not using Docker Desktop.
Okay.
Good catch, though.
It's a long story. Yeah, which is why I thought, okay, so is there a point in using Docker if there is Podman?
Sorry?
If there is Podman as an
I have to admit, and now I hope you don't think less of me, I haven't used Docker at Dynatrace at all. I used it a lot at my previous company. And back then, Podman wasn't really that advanced, so I really don't. I know a lot of my colleagues are using Podman. They prefer it over Docker, so probably not.
Basically they're compatible, but for a large org, Docker is not an option anymore.
Yeah.
As long as desktop is used, it's like
Yeah, that's true.
And Podman you can just, it's a different command, same hardware.
Yeah.
So it works very nicely. My only question was more technical. So when you run containers, those containers tend to produce a lot of logs. So what's your strategy to deal with those logs? Because they grow and take more and more space. And by default, you would not have it set up to truncate.
You mean in an actual production environment?
Yeah.
I have to say for this, you would need to grab somebody else and ask them.
Okay.
I'm really sorry for that. Sorry?
You're working at a company that could help with that. You don't need to do the whole thing.
For me personally, it's more, I'm thinking about setting it up when I switch my PC again because I know the native setup was incredibly terrible to get that to run. And if I have an actual build container for that, it would make it a lot easier. So this would be my use case for a development setting.
Yeah, it's still nice. I would say that there is one use case which is also handy sometimes, that you can actually change the running container and export that into an image.
Mm-hmm.
Because sometimes you just, screwed up, or you don't really have access to the source. You can either rebuild, basically wrap around the same Docker image, or to me it's like a better choice. You customize it, drop it into an image, and then ship it.
Yeah.
Maybe one important thing. So back in the day, we built our websites locally, and then we SSH'd or FTP'd into some server, pushed our PHP files there, and started them there. I'm too young to even remember those times, so I already did it differently. So you showed how you built this container. They are now taking up disk space on your machine, but you said we don't want to ship your machine, or not the physical machine. So how do those container images get into production in a real environment?
So it depends on the setup. I remember previously at my company, we just pulled the images that we wanted. We had our own repositories for our locally built Docker images. We pulled them and then we run them.
So, and of course, your build pipeline pushed to this central repository.
Exactly. But I guess this is still a very unadvanced setup. So people that are actually working with this in bigger organizations probably have a more refined workflow.
Yeah, I
But
might add, you don't just push it.
Yeah.
You keep your local repository, but you also scan those containers with Thrive or something like this.
Yeah, exactly.
I'd be interested in, like you split it up before into stages.
Yeah.
Can I move one stage in one Dockerfile and have the second stage in another Dockerfile calling the first one? Like,
I believe it. I would say it's possible, but I've never done that.
okay. That would be cool.
Yeah, sure.
Yeah, are there any reasons for using Docker outside of like production environments? Like, is there any reason why you find it useful to use in like in your hobby projects?
For me, I think my main use cases for Docker containers at all were at during the development process, and I believe it would be quite similar to what you have shown at the very end, with that you're able to set up your machine rather easily. For me, I remember I've done a lot of Java to native or some native compilations and all of those things. And for this, I built the file once, I save it to my GitHub, and then I can change machines, run it. If I have a Docker running, then I know I can take my Docker file and I'm able to build my project. And this is mainly the use case that I had with Docker.
I actually use that at home quite often because, let's say you want to run some AI on Llama, for instance. You don't want to touch your own machine. Just start the Docker container and you're done. Yeah, it's very nice.
Or sometimes I have built some different Java versions locally, and all of them need their own GCC versions that they're compatible with. And then this would be another use case to have your Docker file to build your Java 17, your 21, your 25. Yeah.
Just like managing different versions.
Exactly. Yeah.
Also very useful to development database. For example, if you need to install Postgres database, a lot of next button checkbox, you don't know what to choose, just install Docker with default users and then remove it. That's it.
Yeah.
Isn't there a whole operating system that puts everything into Docker containers? Or maybe that's something
Maybe.
for you.
Yeah, I think you're talking about NixOS.
NixOS?
Yeah.
Is
It's
it
like
really
building
using
the-
Docker containers?
Not really Docker containers, but like Dockerfile-like stuff.
Okay.
Yeah.
Maybe it's a weird use case, but that is actually, so that the testing thing, that's a very common one that I also encountered. Also think about your Jenkins server. You don't want to install dedicated software on your build pipeline, but it's easy to tell it to start a specific image, and then you can run the same thing locally as your build pipeline is running.
Okay. Any more questions, or maybe also remarks? I'm happy to take feedback as well.
Maybe share the CSS later. Is this code available somewhere? Maybe. What would be the best way to get into Docker if this was just too fast, or I just want to look it up again? What is your go-to resource?
Like, I think for me, I try to show the process that I personally have. So what I do a lot, maybe there are better ways. I exec into my container with an interactive shell and see what's going on, so that I can build the next step. So I start from my base image, usually a large Ubuntu, because this is the one that I use personally at home a lot. And then I'm just going from there. And it's just one command at a time.
But let's say I forgot all the commands that you listed. What's your go-to reference?
It used to be the Docker website, but now I have to admit it's Copilot.
Okay.
But yeah,
Probably better anyways.
probably.
Can you go to website quickref.me?
That's phishing.
Maybe
Now it's everything you just asked you need.
Okay.
There was a sign with phishing attack. I don't know.
Yeah,
Check the link.
we can check it later.
Yeah.
Oh, sorry.
Okay. So everything is in the common training data of current LLMs. That's nice.
Yeah, I had no problem setting up the example, or searching for the commands that I needed for this demo.
So if there aren't any more questions, then let's have another round of applause.